This is your video for Variables and Patterns 4.2. Hopefully you guys can understand me despite trying to record this with my cold. But anyways, we're going to start with always making sure that we know what our learning target is. And for this video, our learning target is to recognize and create expressions that are equal. That means that I want to revisit the definition of expression. So expression would be a combination of numbers and variables and operations. So your add, subtract, multiply, and divide sign. So some examples might be, let's say, 3x plus 4. Another example could be 3k. An expression could be 7 plus 9. So it's a combination of things. Equivalent expressions, well, 2 or more, so I'm just going to write 2 plus. Tuplet expressions that are equal. So an example could be, let's see, n plus n plus n, so that's an expression. But that expression would be equal or have the same value as saying, well, there are 3 n's. So these two have the same value. Another expression could be, let's see, 4 plus 2k plus k. And that's the same thing as saying 4 plus 3k. So hopefully that gives you a little bit of idea of what two equal expressions look like. Now terms are the parts of an expression. They could technically be called the parts of an equation. Oops, running out of room. But, I mean, I'm going to put it over here. They are not the operation signs. So terms do not include the add, subtract, multiply, and divide. So in our first example, going through that, we have 3x plus 4 plus 8j plus a negative 9. The first thing would be to look at what is not an operation sign. So that means that each one of those things that I underlined is a term. So on the line, we would make a list. One term is 3x. And because they're squished next to each other, you don't separate them out. That's one term. Then a 4. Then an 8j. Again, they're smushed next to each other, so we leave them together. And a negative 9. And the second one, you do have to make sure that you list these two variables, even though they're the same, you list them twice because they're in there twice. So ignoring the operation signs, underlining, that means that I have an h, another h, 24, and 17. So far both of those had 4 terms in them. And in the last one, if I ignore the operations again, I have well, that's actually a negative b, a 9k, and a 7.8. So this one has 3 terms. You do need to include those negative signs. So negative b is one term, 9k is the second because they're squished next to each other, and the last one is 7.8. So another way that you could think about doing those would be to either cross out or highlight the operation signs, and then what you're left with are your terms. So let's look down at our equivalent expressions, or needing to create, equivalent expressions. So one thing with creating equivalent expressions, you want to look for things that you can combine if possible. So in this first one, I see that I have 3 n's. So I can shorten that mathematically to say 3n. And then I still have to include the plus 2. So these two right here are equivalent expressions. Now there's another line, because one thing that I don't want to see is, even though these two right here are equivalent, I don't want you to get in the habit of always just flipping an addition or a subtraction. I want you to understand further that when there is something to combine, do that versus just flipping things around. So in our second example, we have a 4K and we have an 8K. Both of them have the same variable. That means we can combine them together. So I would have a total of 12K. Now there is one other option to making an equivalent expression. And the first one that I did, I combined the variables. But to make an equivalent expression, you can also uncombine them. So this second line is really short, but I could separate them all out. K plus K plus K plus K. So there's my 4K. And then I could say plus 8K. That is one way of doing it. I could write out 12 K's in a row, adding them all together. I could do the 4K and then make 8 of these. So sometimes there's a lot of different options to making an equivalent expression. All right, 3 times 3. It's an expression that I can solve, but I don't want you to do that. Okay, I don't want you to solve it, because that's just a number. That's not an expression. So, no go. What you can do is say, well, 3 times 3 is the same thing as 3 squared. So it's a different way of representing the 3 times 3. All right, and the last one, just kind of like the second one, we have a couple of options. I can look for what I can combine, which are my K's. It's probably the easiest. So that gives me 7K plus 7. But I could separate everything out. So it's long, but I can do 6Ks Let's see, 1, 2, 3, 4. One more. And then I could do plus 7 plus k. Or I could put all the k's together and put 7 on the end. So both of these are correct ways of coming up with equivalent expressions. So basically, what you need to take away is that you can combine variables or you can list them all separately. That's two ways to make equivalent expressions. So these notes are pretty short, but that will get you what you need to prepare for class when we do work on 4.2. If you have any questions about these notes, make sure that you come prepared for class, ready to ask them.